All right, welcome to this explainer. Today, we're embarking on a massive cosmic voyage to uncover the hidden secrets of our home galaxy. We're going to zoom way out, far beyond our own solar system, to unravel the massive, swirling mystery that we call home. Okay, let's dive right in. What if I told you that the night sky is actually hiding the real universe from you? Seriously, when you look up on a clear night and see that faint, hazy band of light arcing across the sky, you are only seeing the central disk of our galaxy edge on. The rest of this gigantic structure, it's hiding in the dark, just waiting to be explored. So, what exactly is this massive thing? How big is it really? And what unbelievable things are lurking right at its center? Well, we're going to answer all of that.
Section 1. Our place in the cosmos.
Now, before we can even begin to understand the galaxy as a whole, we've got to pinpoint exactly where we are floating in this vast cosmic ocean. We need to find our address. Imagine the entire Milky Way as a giant glowing pinwheel. We are located roughly 27,000 light-years away from the galactic center, perched on the inner edge of what astronomers call the Orion Arm. To put that massive distance into perspective, even if you could somehow travel at the speed of light, it would still take you 27,000 years just to reach the core. We're essentially sitting about halfway from the center to the outer edge of the disk. And to really wrap your head around this enormous scale, you have to realize that everything in the galaxy is moving. It takes our entire solar system about 240 million years to complete a single orbit around the center of the Milky Way. Think about that for a second. That means the last time Earth was in this exact position in the galaxy, dinosaurs were literally just starting to roam the planet. Mind-blowing, right? So we sit in a very specific, quiet little neighborhood known as the Galactic Habitable Zone. We're hovering roughly 5 to 30 parsecs above the central plane of the disk, safely distanced from the absolute chaos that happens closer to the galactic core. We are, for all intents and purposes, living in the quiet suburbs of the universe. But this raises a massive question. As we zoom out from our safe little bubble, what kind of structure are we actually inside? If we could somehow fly up and look at the Milky Way from above, what would we see? Section 2. Traversing the Spiral Arms. If we zoom way out, we see that our home is a barred spiral galaxy. It's this vast, flat, spinning disk filled with anywhere from 100 to 400 billion stars, along with staggering amounts of interstellar gas and dust. Now, the Milky Way has 4 main branching spiral arms extending from its center: the Scutum Centaurus, Perseus, Norma Cygnus, and our local Orion Cygnus arm. But here is the really surprising part. These arms, they aren't solid permanent structures like the spokes of a bicycle wheel. They're actually much more like cosmic traffic jams. You see, as density waves ripple through the galaxy, they create these spiral arms, and the whole structure acts as a giant stellar nursery. Through a process known as orbital resonance, massive clouds of interstellar gas are channeled inwards. It's this incredibly dynamic environment where the raw ingredients for life and light are being pushed together, fueling furious, rapid starbirth. The absolutely crucial point here is this step-by-step chain reaction. First, gas falls into deep gravitational wells, causing the pressure to absolutely spike. This extreme pressure gives birth to massive, hot, young stars that light up the surrounding gas, creating these brilliant spots known as HI regions. And when these massive, short-lived stars eventually die in violent supernova explosions, their shockwaves plow right back into the surrounding gas clouds, triggering a chain reaction that builds even more stars. It's a continuous engine of creation. So where do these spiraling stellar nurseries lead us? Well, scientists later discovered something unbelievable waiting in the dark. If we follow these bright, spiraling lanes of gas and newborn stars all the way inward, tracing them back to where they all converge, what exactly is waiting for us in the mysterious center? Section 3. The Heart of Darkness. Journeying past the inner 10,000 light-years, we enter the central bulge. The stars here are ancient, packing together incredibly tightly to form a brilliant, elongated bar of light. But hiding behind thick walls of cosmic dust is something terrifying and magnificent. At the very core of our galaxy lies an intense, completely unseen radio source, known to astronomers as Sagittarius A star. For decades, scientists watched stars at the center of our galaxy whipping around an invisible point at millions of miles per hour. Something unimaginably dense was pulling on them. That invisible point? It's a supermassive black hole, And the scale of it is just mind-bending. Sagittarius A star contains the mass of roughly 4.1 million of our suns, crushed into a space smaller than our solar system. Its intense gravity acts as the anchor for the innermost part of our galaxy. However, that is only part of the story. Here's a massive mystery that puzzled astronomers for decades. If you calculate the mass of the 400 billion stars, all the gas, all the dust, and even this incredibly heavy supermassive black hole, it's not enough. There simply isn't enough visible gravity to keep a galaxy spinning this fast from just flying apart into deep space. So, what on Earth is holding us together?
Section 4. The Invisible Galaxy.
To understand this unsolved mystery, we have to look at the scaffolding that we literally cannot see. The galaxy we observe, the stars, the light, the dust, is actually just the tip of the iceberg. The vast majority of the Milky Way is made of dark matter. It forms this gigantic, invisible, spherical halo that extends way, way beyond the spiral arms we can see. Now, we don't know exactly what dark matter is made of because it doesn't emit or reflect light, but we can absolutely see its gravitational pull. This invisible ghost is the true master of the galaxy. Without its immense mass, the Milky Way's disk would instantly tear itself apart. But here's the thing. That dark matter halo isn't entirely empty. It contains ancient population 2 stars that are nearly as old as the universe itself. And it also holds these ghostly structures, like the Magellanic Stream, which is actually gas being brutally stripped from satellite galaxies, and the monoceros ring, a ribbon of stars torn from another dwarf galaxy entirely. You see, the Milky Way isn't just a peaceful neighborhood, it's a predator, slowly consuming smaller satellite galaxies.
Now, this discovery completely changed how we view our home. We are growing by eating our neighbors. But what happens when a predator meets something larger than itself? What happens when we finally meet an equal?
Section 5. The Ultimate Collision.
Let's zoom out one final time, way beyond our galaxy, into our cosmic neighborhood known as the local group, and look deep into the future. Our nearest giant neighbor in the local group is the Andromeda Galaxy. It currently sits about 2.4 million light-years away. It's a monster spiral, even larger than the Milky Way. And through the silent void of intergalactic space, Andromeda and the Milky Way are being pulled together by their mutual gravity, rushing toward one another at hundreds of thousands of miles per hour. Looking at our cosmic timeline, we can trace our history from our birth about 13.6 billion years ago, through an ancient merger with a massive galaxy dubbed the Kraken 11 billion years ago, right up to the present day where we are currently snacking on the Magellanic Clouds. But our ultimate destiny, billions of years from now, is an inevitable massive collision with the Andromeda Galaxy. The two spiral giants will completely smash together, warping their structures to eventually form one massive elliptical galaxy. But what happens after that? Well, trillions of years after that cosmic collision, the universe is going to look very, very different. The great stellar age of star formation will finally wind down. The last tiny, long-lived stars, the red dwarfs, will slowly fade away. Eventually, the galaxies will go completely dark, leaving only compact objects. We're talking cooling white dwarfs, dense neutron stars, and wandering black holes moving silently through the pitch black. But for now, our galaxy is bright, violent, and incredibly beautiful. We have explored only a tiny, tiny fraction of our home galaxy. Somewhere out there, hidden among hundreds of billions of stars and dark matter halos, countless mysteries are still waiting in the dark. And perhaps one day, they'll be discovered by us. If you enjoyed this cinematic journey through our galaxy, make sure to subscribe to the Explanation Lab for more amazing science explained. Keep looking up, and I'll catch you next time.